So if John can drive 330 miles in 6 hours, how far will he be able to drive in 18 hours? Think about how you would solve that problem. Start it and see what you get. More importantly than the correct answer is how you got the answer. So a proportional relationship between two quantities is a relationship in which the ratio between the two quantities is always the same. The painting problem. 1 quart of paint is required to paint a wall that is 6 feet by 8 feet. How many quarts would be required to paint a 12-foot by 16-foot wall? Now be careful because this problem can be a little tricky. You'll want to make sure you draw a picture so you get the correct answer. Okay, there's a picture. So we have 6 feet by 8 feet, which is 48 square feet. And then 12 feet by 16 feet is actually 192 square feet. So just because you double the dimensions doesn't mean you only doubled the area. So be very careful with a problem like this. So now you need to find out how many copies of 48 are in 192. There are 4 copies. So if you needed 1 gallon of paint for 48 square feet, you need quarts. You need 4 quarts of paint to paint your 12-foot by 16-foot wall. Proportionality. We can think of proportions as when one quantity is multiplied by a constant, then the corresponding quantity is multiplied by the same constant. We see this in geometry with similar triangles. The triangle on the left, the base is 2 and the height is 3. On the triangle on the right, we've changed the base from 2 to 3, so the height has to change proportionally. So since from 2 to 3 is 1.5 times, or 3 halves, times as large, we have to multiply the 3 by 3 halves. And we would get 9 halves, or 4 1/2. We can also talk about proportions or ratios as mixtures. Suppose you're making green paint. You have 2 vats of paint, each containing 2 cans of blue and 5 cans of yellow. In order to extend one of the vats, someone adds 3 cans of blue and 3 cans of yellow. Did they do it correctly? No, they did not. We had a 2 to 5 ratio originally, and now in vat 2 we have a 5 to 8 ratio. So that is not consistent. You would still not have the same shade of green. Taper strip diagrams. For a certain shade of orange paint, the ratio of yellow paint to red paint is 5 to 2. Let's use the following strip diagram to find 6 different quantities of yellow and red paint that will produce the same shade of orange. You can see that for the yellow paint, I drew 5 yellow rectangles, and for the red paint, I drew 2 red rectangles. That's for the ratio of 5 to 2. So I can use equivalent ratios. I can say, okay, I'm going to double the amount of red, which would double the amount of yellow. And so on. So I can move through this very nicely and figure out all the different quantities of yellow and red paint that will produce the same shade of orange. Double number lines are another way to model proportional relationships. Driving at a constant speed, you drove 14 miles in 20 minutes. How far will you drive in 1 hour? Well, we have 2 number lines there. The top is distance, the bottom is time. So at 0 miles, we haven't done anything, so we've spent no time. Once we go 14 miles, that's equivalent to 20 minutes. Then we can double that, 28 miles in 40 minutes, and double that. Not double that, sorry. If we continue in these 20, all right, let's start this over. Using double number lines, driving at a constant speed, you drove 14 miles in 20 minutes. How far will you drive in 1 hour? You can draw a double number line. You start at 0 miles in 0 minutes. The top is labeled in distance, the bottom is labeled in time. So in 20 minutes, you've gone 14 miles. If we go another 20 minutes, we've now gone 40 minutes, or 28 miles, because 14 plus 14 is 28. If we go another 20 minutes, we're now at 60 minutes, which is 1 hour. And if we add 28 plus 14, we get 42 miles. So in 1 hour, we've driven 42 miles. Now it's your turn to practice. Brittany is driving at a constant speed of 11 miles every 12 minutes. How far will she travel in an hour? Try using a double number line to solve the problem. All right, here's my double number line. So miles on the top, minutes on the bottom. In the first 12 minutes, Brittany goes 11 miles. In the next 12 minutes, she goes 11 more miles, so now she's at 22 miles in 24 minutes. Another 12 minutes, she's at 36 minutes and 33 miles. Another 12 minutes, she's at 48 minutes and 44 miles. And at the last 12 minutes, so 60 and 60 minutes, she's gone 55 miles. So she's gone 55 miles in 60 minutes, or 1 hour. You can also use a ratio table. A batch of purple paint is made by mixing 2 pails of blue paint with 3 pails of red paint. Show equivalent ratios of blue and red paint in the following table. So notice we have a chart and we have the number of batches at the top. Remember we use 2 pails of blue paint with 3 pails of red paint, so that gives us a total of 5 pails produced. Okay. We can fill in the following table, and you can see that we are holding the ratio true the whole time. So if we want 10 batches, we need 20 pails of blue paint and 30 pails of red paint, and we will produce the same color purple.